All right, Brian Keating, thanks so much for joining us today.
No, it's great to meet you finally, Jake. You're quite persistent.
Oh yeah, how many? It's been 2 years, I think.
Two
Been following
years
through
since
with
they
you.
gave you
Yeah.
an assignment and you followed through. So I can't I
Oh,
can't you're better than a lot of my students. So
there
give
we
you
go.
credit.
Well, thanks a lot. So, for those who haven't seen you on Joe Rogan or seen your other podcasts or read your books, can you give an introduction to who you are and what you want people to know about you?
Yeah. So, in terms of my different hemispheres in my mind, I break it into work and non-work, and most of what dominates my work is research into the origin of the universe, the Big Bang. Lately, I'm getting a lot into AI systems and what they can do for fundamental science and experimental science. So I'm an experimental cosmologist, which doesn't mean I do hair and makeup. It means I do experiments that look and search and hope to find evidence for the origin of the universe, the existence of black holes, the possible existence of other planets and life, maybe on those planets, all within the purview of what a cosmologist can do. And outside of that, yes, I have my own podcast, YouTube channel, which I use to interview, so far about 22, 23 Nobel Prize winners and top thinkers and some people that have left this earth, which is the most treasured interviews I have. Three or four of my guests, not because of my interview, Jake, but
That's right.
because of time's scythe taking them at the ripe old age of 99 in one case. So
Wow.
I'm not too distraught over it, but I really cherish the conversations I have because most of my work is not stroking my, graying beard and looking up at the cosmos, although I do get several moments to do that a week. But most of it's, dealing with people I have to talk to, things I have to do. And the podcast gives me an outlet for things that I want to do. And some of those things involve writing books. I've written 4 books, working on my fifth one now. And the podcast is sort of a labor of love where I get to talk to people just like you, intelligent people that are curious about the state of the universe. And my most controversial opinion is that scientists owe the public, the explanation for what we do, and the failure to do so will result in the termination of the job that we would do for free, which is to explore the universe. So I try to give back in that way, and I give my colleagues crap for not doing it when they don't do it, and I salute them when they do it. So those are kind of my work hemisphere things, and then outside of that, I'm a father, husband, do my best to do that. And I also am very involved in my synagogue, my temple here, do a lot of stuff involved with my Judaism. And I also very much enjoy being, kind of involved in the local San Diego sports scene and doing all sorts of fun stuff like that. So I do a lot of things, probably not, not the best at any one of those, but I think putting them all together, it's a pretty fun combination.
Amazing. And focusing on your work in science, what do you think about the developments in AI over the last 3, 6, 12 months? Is that going to materially influence the trajectory of let's say your work or others in your field? And one example I thought of was a few days ago, researchers applied a machine learning technique to uncover unexpected features of the non-reciprocal forces that shape the behavior of the many body system. I don't know if you saw that, or that was a headline. So they're saying that AI is already influencing the speed of development in some cases of physics discoveries. Is that aligned with
Yeah,
your?
well, it's certainly true that AI is had a tremendous impact and has tremendous potential. The question is, what kind of AI and what will it eventually, be able to do? And from my perspective, the breakthroughs are sort of incremental. There have been, just massive headlines. Everything's, coming for every job under the sun. And I just feel like that is completely off base and it's completely counter historical. If you look back at history, the great breakthroughs that we had were not precipitated by, the computer or now there have been many advances because of the computers, but if you look at the classical discoveries in the pinnacle of science, which I am not a member of, but, theoretical physics, for example, or mathematics, et cetera. I'm an experimental physicist. I'm not a theorist. So I can speak to their credit of what they do. None of it involved like, oh, the calculator and the slide rule, the transistor and the microprocessor. those are extremely powerful augmenting force multipliers, and I use them every day, and I'm using them right now. As a matter of fact, I'm doing some AI, kind of work, deep research on a new theory that I'm trying to test using an optical telescope. But besides that, the question of whether or not the style of deep learning, which is the predominant form of AI that we're familiar with in the LLM space, that these are, kind of these saviors that are going to come, basically to the rescue of physics and break it out of the rut that it's supposed to be been in for 50 years since the string theory revolution. I think that's all nonsensical. And the reason is that they're too damn good. If I could go back to save physics, I would cause Jeffrey Hinton and John Hopfield. I'd put them in, in a timeout for many years, because I think that the neural network and the LLM architecture is so successful. It's just gobbled up everything. It's kind of like, the internal combustion engine. It's so successful, it gobbled up a much better, superior alternative, the electric motor. I mean, imagine if you had the opportunity to start over again and have, start with the electric motor, electric vehicles, and then you had to convince somebody to get a gas powered car, which so
Yeah.
I think that the AI systems that we are familiar with, LLMs plus GPUs, are not going to lead to at least new discoveries in my field in physics, but they may be, extremely powerful for coding and for, generating transcripts and doing all sorts of great stuff. The issue is that, physics is not a language. It's not certainly not a language that is informed by a corpus of knowledge that's reinforcement trained on, the past history of humanity on the internet. That's not how Einstein, he didn't scour all of civilization, from ancient Macedonia to modern day, Bulgarian poetry, and then all of a sudden come up with the theory of relativity. So I think that that's far fetched, and that's not the way physics works. So it's going to have tremendous impact on all forms of science and society, but it's not necessarily going to have the breakthroughs that I'm most interested in. And I've was pleased last week to see Demis Hassabis, who won the Nobel Prize in Chemistry in 2024, proposing a similar test that I proposed in 2023 and have been working on for quite some time, which is to see if an LLM system can reproduce the physics that Einstein did, just given the knowledge of science that Einstein had in 1911, say. So if you cut off all knowledge and you don't allow it to peek under the curtain of what happened in the future, can these tools, replicate what Einstein did? And if they can't, we don't have AGI. We don't have artificial general
Right.
intelligence, because it can't do what a human can do. We certainly don't have artificial super intelligence. So I am optimistic. It gives me the power of 1,000, PhDs and postdocs working around the clock, literally, and I'll give it tasks before I go to bed. And I'm really into it. I set up an OpenClaw server, 8 different times, because it didn't really work that well the first 7, but I finally got that dialed in. I've got subscriptions to every major tool that there is. I use it, all day, every day, but it's really to augment what I do. The ultimate test will be, can it build the conducting super collider? Can it build a large hadron collider? Can
Mhm.
it build the James Webb Space Telescope with no human input? Because that's what humans did. That's the minimum bar. That they have to be able to show in order to prove that I should be worried about them, taking my job or my colleague's job. So they may take over parts of it and things like, education. We could talk about that. I think that's ripe for disruption, as they say. But I'm not worried about it in terms of, taking my job just yet.
Right. And along those lines, like as someone who understands the limits of physical measurement, do you think there's a hard ceiling on what silicon-based intelligence can understand about the universe?
um,
Things that require embodied physical
There's
intuition,
no hard
for example?
ceiling. I think, anything that's a universal computer is capable of doing everything that we can do. I mean, we may have a ceiling. It may be that we have a ceiling, and so everything has a ceiling. As far as we understand, any kind of computer, even a TRS-80 from when I was, 7 years old, could theoretically have no limit as long as it can do enough computations. Now there are hard limits in terms of the age of the universe, the lifetime of black holes and Hawking radiation, the practical so-called limits are trillions of year limits. But in principle, no, there's nothing that prevents them from discovering everything that's discoverable as far as we know.
And then what's the most important question in cosmology that you think AI could help us figure out in the next 5, 10 years?
I think we're Yeah, so the most important question I'm, convinced of because of perhaps my bias, and that's what I work on for the last 20 years is how did the universe begin? I think that's the ultimate question. It's sort of like asking, a biologist what's the ultimate question in biology. They may be
Sure.
partial to their own field, but how did life begin? Not just on Earth, but in the universe, because they may be interrelated. And I'm curious about that too. So I think the ultimate question in cosmology is how does the universe begin? How do you go from a non universe to a universe? How do you go from non matter to matter? How do you go from matter in simplest possible form, hydrogen, helium, protons, neutrons, electrons? How do you go from that to organic chemistry? How do you go from organic chemistry to biological simple molecules? How do you go from molecules to, large life form cells? How do you go from, prokaryotic cells to eukaryotic cells? How do you go from those to mammals to, all these different contingent things, but they all start with the Big Bang as the Big Bang Theory television show theme song highlights. Everything has to start with the Big Bang. So in
Yeah.
cosmology, that's the most important thing that I feel I can study, and that's what I've dedicated the experiments and the careers of the scientists that work, in my lab. That's what we're working on.
And what about the AI hype, frustrates you the most as a scientist? Is it what you just said about people thinking it's going to take over everything, or
I think it's,
what?
that they don't really have any humility about it. Like there's more to being, a scientist or even a citizen or anything than just raw intelligence. I mean, some of the most important intelligent people in the world are in the Epstein files. My name's in the Epstein files, but I'm not, fortunately it's because I attended a conference, not because that he supported. He wasn't even there. And some of the most brilliant Nobel Prize winners are in these Epstein files. They're far more intelligent than me, and yet they have no wisdom, or they had very little wisdom, or they had, horrible, horrible, sociopathic behaviors. Some of each category are probably true. And so, no, raw intelligence should never be confused with anything approaching wisdom. I think what we could use is artificial wisdom, more than artificial intelligence. I mean, we've had a tremendous intelligence for since the internet came around. Wikipedia is far smarter than any human being, but in terms of raw knowledge and even speed and processing, I mean, we've had supercomputers and super intelligence, if you narrowly define it as ability to do math problems really quickly. We've had that for, 55 years or 60 years now. But that's not what most people care about. I mean, I care more about, the person that I'm interacting with, their wisdom, and, someone taking care of your kids. You don't really care how smart they are if they're evil, malicious, malevolent people, just because Stephen Hawking is so brilliant. He went to Epstein Island multiple times, so what are the actual implications of intelligence? I think they're way overstated.
Got it. And it's more, and we need to balance that with like wisdom and morality
Yeah, I think that we
and
we don't
things
have
like.
any ethical training. I mean, as scientists, we get none. I
Hmm.
mean, it's funny, we make fun of our colleagues in the business school, oh, they just care about money, or the law school, and they just want to be run the world or whatever. And then the medical students, that come to our classes, we always kind of say, oh, they just care about getting a good grade on the MCATs. But all those three disciplines, business, law, and medicine, have ethical training requirements for their students. We don't have any of that. We just say, "Oh, you'll pick it up by osmosis," and I'm like, "Oh yeah, you're going to pick up quantum mechanics by osmosis? Oh no, that's really serious and important. We're not going to pick that up by osmosis. So why don't we teach ethics the way we teach quantum mechanics? Oh, well, we don't have time, or no, you do have time. You just
Yeah.
don't want to prioritize it.
Huh. That's interesting. And so another question back to the thing you brought up earlier about, it sounds like you don't believe that AI is going to come up with any novel scientific
I
theories, right?
I
Like it
wouldn't
can
say
help
that. I
us.
wouldn't say I don't think they're gonna come up with any novel. I think they're gonna come up with novel things. I just think the biggest, most important things that I care about, understanding new theories of unification of forces and fields of matter and energy, of the ultimate, model that describes how the universe began. I think that they're, as incapable of doing that as, a computer in 1965 when computers were brand new. They weren't able to just necessarily predict the existence of dark energy. I mean, that took human insight to kind of conjecture, and then later it took observation. So I don't think it's possible as a scientist to conjecture things and then prove them without any human contact with some way of acquiring data. I mean, you could say that the humans might, will work for the computers, and there is a rent a human function that you can hire. These Claude bots have been hiring humans to do things like captchas and all sorts of things. So that's not really what I mean. I mean, someone has an idea for something or discovers I mean, half of the most interesting things are discovered serendipitously. The CMB, the cosmic microwave
Mm.
background that I study, was discovered serendipitously. And I always say it's very hard to plan on serendipitous discoveries because by definition, you don't know them when they're going to happen. So how does an AI, really enhance that? In one sense, they can't. In another sense, you can't, ignore how powerful they are and how supplemental they are. And they should be used as a complement, not a supplement for what physicists do.
So with the CMB, so you co-lead the Simmons Observatory in Chile. So how
Simon's
could an AI?
observatory, yeah.
What did I say? So how could a so do you think an AI driven approach like the one used in the Dusty Plasma study be applied to CMB data to find physics that we're currently missing?
Um, it could be.
And just to elaborate a little more, like CMB is the ultimate many body data set, right? Billions of interacting photons from the early universe. So is anyone really applying physics informed neural networks
Oh yeah,
to
yeah,
it?
yeah,
And
for
then
sure. I mean, right now, the where we're at with physics and a lot of understanding of high energy particle interactions and cosmological interactions is we're drowning in data. We have tons and tons of data, which wasn't the case 50 years ago. There's no data. There was like 10 galaxies that we knew about, and then we had their redshift, and we saw they're higher than the redshift seems to be that they're moving away from us. So cosmology was really data starved for the first 30, 40 years after 1929, and Hubble and Einstein and Lemaitre kind of conjectured that the universe began in a hot, dense state. And then it wasn't until the discovery of the cosmic microwave background, this 3 Kelvin, all pervasive radio wavelength, microwave wavelength radiation that bathes us in a constant 3 degree Kelvin glow, that we had a precision number. Finally, we had a physical, cosmological observable, a temperature, which we could convert to a density, which we could convert to, basically an ionization fraction of the universe. That we had a quantitative science rather than a qualitative science. And since then, it's just exploded. I mean, we've got new telescopes. The Rubin telescope came online last year. We're going to have, the upcoming Nancy Grace Roman telescope is launching soon. We have, the James Webb telescope, obviously, Hubble Space Telescope, the Simons observatories came online 2 years ago, is going to release data in the next year or so. It's just, it's a golden age for data, but we're drowning in it. And each day of data, we get about a terabyte worth of acquisition. Now, we don't keep all that data, but imagine like your hard drive fills up every day, and a lot of it, and when the weather's good and the seeing is good and the conditions are right, you want to keep 500 gigabytes of that 1 terabyte, and it's every day for 10 years. So you're talking about petabytes of data. And my colleagues at the LHC will laugh at me. That's like they get a petabyte in a couple hours, but they throw away 99.999. They have 6 events over 12 years. That's a big deal for them. So we're in different regimes. So AI is perfect for that. AI, machine learning, just incredible data sets. But the math is not that complicated. I mean, AI, LLM math is not complicated. It's basically what's known as linear algebra, matrix multiplications, diagonalization, gradient descent method. It's very powerful that they were optimized, but they came out of serendipitous. They were serendipitously discovered too. They came out of the computer gaming field where GPUs were needed to blast pixels at a high rate to a monitor. And so there's nothing like that has to do with how a new field theory might come about. But on the other hand, it's very good at image analysis, which is one of the things that we do as one of the preliminary steps that we do on many different branches of astronomy and cosmology. So no, they're going to be very useful. And they may come up with things. Like I had to do things, where I felt like, well, this is kind of magical, where it kind of surfaced something. It was actually from my books and podcast. Like I fed it every transcript I've ever done. And, it's a huge, 1,700 total videos, audio, fed it all in. I don't know if it, what it does to it, to be honest with you, how it compresses all that information, but it was a 40 megabyte text file. plus my books, 4 books, plus every appearance I've been on other people's podcasts. Like this will go in it to the next version, right? So I fed it all in, and then it surfaced like really interesting connections. And I remembered writing it, but I didn't. The good thing about having written books before ChatGPT 3 came out is that no one can claim I wrote it with the help of AI. So I'm kind of proud of like that it resurfaced some, and it really picked out some things in my childhood and the connections between, say, science and religion that I didn't think about so much when I was writing my first book in 2018, to now when I'm writing my fifth book, and it was just kind of magical moment where it surfaced this thing. And I could imagine it doing the same where I'm looking for this very peculiar type of polarization signal from the early universe. And also looking at how like a crystal behaves on Earth and saying, oh, I have data from that in the lab. There's only one universe. There's many crystals. Maybe it's telling me to put these things together, not like magical woo woo crystals, but study the behavior of optical polarization in the laboratory as a tool to understand the polarization in the universe. I felt that was really clever. And so there are magical things about it for sure. And it's just not clear to me that the main limitation, as you know, for a lot of these LLMs is the training data. And it's just vast. And that 40 megabytes of data took me 10 years, more to assemble, right? So it's not like it's easy to get the data. And so what do the companies do now? They do two things. They either generate data themselves after they stole a lot of data, including my books. Anthropic has admitted that they, basically scanned 500,000 books and and then burned them for some reason, which is very strange. But they scanned all this, so they stole basically intellectual property from people. But then then they're using people to do reinforcement learning using humans, and then they're also doing training data, and then the Chinese models are basically sampling the American models or the French models or whatever, and they're doing what's called distillation, and they're basically, reverse engineering what the weights are. And so if the weights are so dependent on data, then that data by definition was recovered in the past. So it's only past looking. So it can't by definition predict the future. So it would be like looking at 1911 data for Einstein and just saying, no, there's no weird behavior of the planet Mercury. And then we'd be stuck in that prison. So I call it like the GPU LLM prison. I'm not sure. Yeah, I could be wrong. We may discover that a new law of physics tomorrow. And people are doing great things with it, and especially in math and checking stuff and proofs. But it's not, if as far as I know, it's not able to pass this test that I coined, the Keating test, but Hassabis coined the Einstein test. And I think that's a better name, honestly.
Well, then I want to get your quick opinion on this article that came out a week ago. I don't know if you had seen this, but AI reveals unexpected new physics in the fourth state of matter. Not sure if you'd come across this, but basically, um, what this had said is that the physicists at Emory had used a custom neural network trained on 3D particle tracking from dusty plasma experiments to infer the forces between particles. And so they figured out that two longstanding theoretical assumptions were wrong, that charge doesn't scale proportionally to particle radius, and also that force drop-off between particles does depend on particle size, with 99% accuracy. So, I mean, this came out a week ago. This
Yeah,
stuff's
I
not
haven't
coming out
seen
every
that,
day,
but
but
I guess the analog for me would be, does it predict what's called the Coulomb force, which is the ultimate electrostatic force? Can it predict Maxwell's laws? Like if you put an LLM and, just again, train it on data from 1860 and before and nothing else. And it's impossible to do that now because the data is so corrupted. And even in physics data sets, like you just have a physics paper corpus of training data, it'll still have like, it'll know somehow about like the Fast and the Furious 3 or Interstellar, and it's very hard to
hmm.
decontaminate it. But I would say, no, things like that don't surprise me. It would surprise me again, because that would be effectively the Einstein test. Like if it predicted a new force of nature, which, some people are claiming, and you always have to be a little bit careful. It's like scientists discover life in another exoplanet, and you have to look really deeply. And what does it mean? Oh, they discovered a molecule which does something tricky, and that's unusually usually associated with life on Earth. Those are all potential biased results. So it sounds like a really cool result, a tour de force mathematically. I don't know if it qualifies for the Hassabis, Keating, Einstein test. I'm going to throw my name in
Yeah.
all those Nobel laureates, but it's certainly, again, it's not really clear what I could do with 1,000, 190 IQ PhDs working for me. Like but you need some kind of orchestrator. I even find this. I don't know if you've used this OpenClaw, uh, yeah,
Yeah.
but I find when
I have it running on this Raspberry Pi
oh,
right
you
here
do? Okay,
actually
you're gonna
as
have
we
to tell me how to set
yeah,
that.
this little
I
Raspberry.
got a Raspberry
Yeah.
Pi, but I run it on a Mac Mini. Um,
You just gotta ask Claude and
yeah, yeah.
yeah, just that's
I'll
what I
I'll
do.
I'll get your tips for that offline. So, I was setting it up and then, like, I was blasting through all my tokens for Claude 4.6, and I was like, "This is crazy," when, like, a lot of it was just like, "Send me my daily weather briefing plus, local papers on the physics archive what's my first meeting?" And it's all it did it, and I was like, "You've reached your session limit on I'm like, "What the hell?" So I figured out how to change the orchestrator from 4.6. I use the orchestrator only in 4.6 and then use other models, Gemini, Flash, and whatnot, right? I don't want to get too nerdy, but you're familiar with it. And I realized that's kind of like what we have to do as scientists. We have to take like we have to be the we have to be the Claude 4.6 or whatever, and we have to have our students and colleagues and you'd be surprised. 90% of my colleagues don't use AI at all. 9% of the remainder are hostile to it for good reason. I wouldn't say there's good reason, but it's causing sort of more problems for academicians like me and professors like me than it seems to solve. If you're an
Mm,
experimental physicist or even a theoretical physicist, like I said, and you're just like a pencil and paper pusher guy or gal, you don't really have much use for it. But we're finding kids are using it to do every single assignment. We found kids are going to the bathroom during final exams and coming back 10 minutes later and getting, identical answers to different final exam problems. And so we're seeing, kind of like only the negative side. So, like I said, 90% don't use it. 10%, 9% use it, but are, kind of vehemently opposed. They're trying to use it to figure out ways to catch people using LLMs. And this is AI versus AI, spy versus spy. And then there's the 1%, maybe like me that are tinkering, get up early in the morning, play with it, have our kids use it. Your kids are young, but when your kids get older, you're going to want them to use it. I have a son who's wanting to learn, differential equations in high school, and I think he can do it. I couldn't do it. I didn't learn, calculus AB until my senior year, and had to self teach myself. But I said, look, you can have this book. You can take like Steven Weinberg's book on gravity and say, explain it to a smart high school student and then break down the calculus into chunks that I've already covered in calculus AB or whatever. And it will do that. And so you can make, and I said, like, tell it not to make any spoilers. Like there's spoilers in calculus. Like you don't think about it like that, but calculus is
mm,
like a
mm,
love story. It's a beautiful one of mankind's highest accomplishments up there with Beethoven and Mozart and Picasso. So
mm,
I don't want him to get spoiled of that benefit. He's reading The Great Gatsby. I'm like, have a reading guide, but always tell it not to spoil it because it will spoil it, but it will also hallucinate. And that's the other problem with it. A lot of my colleagues don't trust it, again, for good reason, because it's very sycophantic. Oh, that's a great idea. I get literally, Jake, I get, probably 3 to 4 emails a day. Professor Keating, I just got one. I could read it to you. I'm not even going to respond to the person. Very earnest people, but they write to me. They're desperate. They're wonderful people, I'm sure, and I would love to be able to help every one of them, but I can't. I have kids and a wife and a family and all sorts of other things. But here's one, that I just got: falsification of the Torah, and then how what is it, the many body problem comes into play, the refractive index that takes place. It causes a function that then decays geologically, and that explains the Torah and the 7 days of creation. And that's one example. That's the least maybe technical one I've gotten. And then I get people that, like, oh, I just want 5 minutes of your time. And I'm like, well, 5 minutes of my time could be worth like $1 million. Like if it's on my deathbed, that's worth a lot, right? So I started
mhm,
charging people. I said, because the LLMs are telling them everything this guy just said. Here's a script that I got from Gemini 3.0, and you can prove that it works. Just run it on your computer. You have to download this model first, and then you download the other because it won't work. I'm like, okay, you're telling me this whole homework assignment. You're telling me it only take 5 minutes of my time. But I'm going to tell you, my time is worth millions of dollars, perhaps per minute. So depending on where I am in my life. So I have a standard thing now. If you want an hour of my time, you can either pay $1,000 an hour, and that goes to charity. UCSD has a food bank, if you can believe it. There are starving or basically food insecure kids on campus, which is a tragedy. I mean, we charge so much for tuition that there are kids that can't afford to eat. Jake, so it's sick. I
Well,
feel like universities are gotten totally out of control, but that'll have to be a topic for our next podcast when you come down here. But the point is that I want to give to these kids, so I donate my own money every year, a decent amount of money. And then anytime that someone wants an hour of my time, I say, you can have an hour, but it's going to cost you $1,000 and you have to donate to charity. And I'm also going to start doing that with podcasts pretty soon because, again, it's just like I have so much cool stuff I'm excited about. I love talking to people like you, but, I have to prioritize. So you got off cheap this time, but maybe next time it'll be a little bit more expensive. Just kidding. But the thing is, it has to go to charity, and then they have an hour with me. If they don't want to do that, I charge $20 a month for a group coaching session. So I've got like 7 to 10 people every month. Yeah, I've 20 or 30 that are subscribed to it, but they don't come. 7 or 10 people have an hour a month with me, and we just talk about their ideas. I love it. But the
well,
problem with these AIs is that they're giving people this kind of this sort of hallucinatory, sycophancy that there are the next Einstein, and that they just need me to sign off with a .edu email address, and then they can get the paper published. I mean, literally, I get people asking me to endorse their papers, to put them on the submit them for publication. I'm not going to do that. I won't do that for
I see. Wait, I'm
anybody.
just trying to connect.
Yeah.
I'm trying to connect and make sure I followed. So the what you're saying about people emailing you, the story there is that they're emailing you to get your sign off on what they think is a
After
discovery. Is
getting
that right?
ChatGPT sign off on it. Yeah, it's always there. ChatGPT has allowed the proliferation.
Yeah. But they're saying, "Hey, I discovered this great, amazing
Yeah,
new
new law of
thing."
physics. Today I had
That
someone call
that
me
that's the spam you're that's the content you're
yeah,
getting from
people call
everyone.
someone
It's
another guy
saying,
called me an a-hole because I
got
wouldn't
it.
sign off on his theory, or I wanted to.
What does it mean sign off? What does it mean sign
So to
off?
get a paper
Like,
published, you have to submit it to a journal, right? And so the journal gets peer reviewed
yeah.
journal. So they have typically you have to submit that from a university, a .edu account, or sometimes a government account. It's very rare you can submit with a Gmail account. And there's another venue by which people publish their papers called the archive. It's actually a public domain service going back 30 years now. It's called Archive
Yeah.
with an X. And it is published at Cornell, supported by the Simons Foundation as well, and that also typically will very highly de-weight people that don't have a .edu email address. So you need something called an endorsement before you can submit of any kind. If I submit and it was my first paper, but I'm a .edu, like my graduate student, when she wants to submit a paper, she has to get an endorsement from someone else, usually like me, and typically they have to have published on the archive, or they have to have a .edu email address to just get above the referees that are there. And that's not refereed, it's kind of like vetting process. So that's what I mean. But what's
Right.
happening is people are saying, I don't want to waste your time. So I had ChatGPT do this. Look at this chat that I pasted 1,000 lines of text in the email, which literally happens. And here's it going through step by step every single equation and verifying it. It's like, yes, Jake, you're absolutely correct. This is incredibly, transformative result. And I can make up like 1,000 different theories right now and have I could guarantee you, we could go to ChatGPT right now. I could come up with some crystal dust plasma theory that explains the CMB, and there's no Big Bang, and ChatGPT will effectively say it's correct. So that's the problem, in that you can make up and you can ask it facts. I said to it recently, Brian Keating, what books has he written? Losing the Nobel Prize, correct. Into the Impossible, correct. A Brief History of Time, not correct. I had it say to me that
Um,
I had this new one that's a chat function on a built-in supercomputer chips called Talus, and they make these chips now that have LLM architecture encoded in the chip. And I asked it, who's Brian Keating? Is like a Jimmy Chat or something .ai. And it came back, Brian Keating is the a cosmologist at San Diego, and he was the former head of the Large Hadron Collider. And so it's like, you
hmm,
can't trust it on facts, but I mean, a couple of years ago, if you
right.
asked it how many R's
So
are in strawberry, it got it wrong. So all the more so
right.
for checking a theory of physics that we don't even know exists, but has never been peer reviewed, identified, or vetted.
Wow. I want to take a 90-degree turn here and go back to something you
Yeah.
said minutes ago, which was that you fed AI all of your podcast content, all that stuff. I wanted to ask you, what were the questions that you asked it after you fed it all that?
I just asked based on the kind of text that you've received. What are my top 5 priorities? What am I working on? What holes am I missing? What connections can you see between these ideas and the different podcasts? I also fed it.
What was the craziest thing you what did it tell you anything you didn't know?
Um, it was kinda like, my personal trainer, like, my personal trainer will say, "Eat less, carbs and work out more." And, like, I know that, but it's good to have accountability, right? To get weighed, to get measured, to get, checked and surfing and lifting weights and all the stuff I like to do. So it didn't tell me anything I didn't know, but it told me stuff that I was unwilling to see maybe or that I didn't wanna see, including aspects of my upcoming book, which, I'm not gonna talk too much about because sometimes you talk about stuff and it takes away a little bit of the thrill of doing the actual thing. You gotta just do the thing and not think about doing the thing or talk about doing the thing.
Hmm.
So for me, yeah, it had this very interesting connection, between this, person in my life that, I was considering writing about, but not sure how to orient it, in the book. They're a private person, and so how do I do that and do it? And I came up with a very warm way to do it. Now I still have to write it. I have to sit down and write it, but the architecture, the skeleton of it, is like the main challenge I'm finding is that to describe this particular physical effect that we're looking for, it is as a ancillary kind of finding and discovery for the Simons Observatory potentially. It involves really very abstract math and physics, like way beyond what's in A Brief History of Time or, The Fabric of
Mhm.
the Cosmos or, Brian Greene's books, as great as they are. They kind of gloss over them. Like string theory is a billion vibrating dimensions in a super high dimensional space of energy. And it's like, okay, what does that mean? And they won't tell you. Or waves are correlated and particles are waves and they have this weird collapse
Hmm.
of the wave fun like they never really explain what that means or why it's a problem. So I want to do it justice, but the problem is a lot of people that are popular science consumers, they're not going to be willing to go through the trouble of learning the math and physics behind it. So how do I do that elegantly? To quote Brian Greene, how do I do that in an elegant way? But it's also like I don't want to sugarcoat it and make it like fanciful because his books and Stephen Hawking's books and Lisa Randall's books and Janet Levin's book, like they don't have to be, they don't have to ever confront reality. Like they could talk about
Hmm.
string theory and say, oh, it's going to be discovered in 2020, 2222, and 200 years from now. Um, I'm an experimentalist. I can't get away with that. I'll lose my reputation, my funding, my livelihood. So from that perspective, an experimentalist has to be a lot more practically oriented. And so those are some of the things that's kind of helping me work through as we speak.
Amazing. Well, Brian, this was
Yeah.
incredible to get a chance to talk to you. It's really an
I
honor.
hope we can meet in person either up there or down here and keep doing what you're doing. Congratulations on all your success. I mean, you've grown a lot in 2 years. That was, I think if I could have your growth, 60x or whatever, since I gave you the homework assignment, I would take.
Um, yeah. Well, yeah, we'll see. It would here. Let me stop the recording and yeah. Well,